First of all, okay, sorry for the error. Okay, so first of all, I would like to greet Mr. Prof. Nambo. Joined us here, and also Mr. Imam Tahyudin, and some student from Kanazawa University. Prof. Nambo, would you like to give some greeting speech maybe?
Okay, can you hear me?
Yes, yeah.
Yes, I can.
Okay, so good morning everyone. My name is
Good morning.
from Kanazawa University, Japan. Today, last week, it was a great opportunity to join this winter course, me and our students. Today, after the keynote speech, our students will make presentation. They may speak in Japanese, but first Imam Takiri will translate. I hope.
Translate, okay.
Very, we are very happy to join this course. Thank you.
Okay, thank you, Prof. Nambo. And maybe a student from Kanazawa University? The representative? Just say hi, or maybe good morning. Ohayo gozaimasu. Yeah. Okay. Oh, they look so serious. Okay, thank you, Prof. Nambo. And then over to Mr. Imam Tahyudin. Would you like to greet Mr. Nambo and participants here?
Oke, Assalamualaikum warahmatullahi wabarakatuh.
Ya, Waalaikumsalam warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you so much to Mama Sensei and the student from Kanazawa University and the student from Universitas Amikom Purwokerto. Today is the second meeting for our program, Artificial Intelligence Winter Course 2020. I wish today the agenda will run fully, and also in this meeting, after the keynote speaker, there are 3 presentations from Kanazawa University students, and the audience, I think, curious, want to know about research from Kanazawa University students. And maybe I wish Namba Sensei will be lead the presentation from Kanazawa University students. Yes, I think maybe as the moderator from Kanazawa University students.
Okay.
And then thank you for the keynote speaker, Mr. Bagus. I think that's all. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Imam, for delivering your speech. And then before we go to hearing the lecturer from Mr. Bagus, I would like to tell you about our agenda today. We will begin by hearing lecturer from Mr. Bagus, and then after that we will have a question and answer session. You are allowed to deliver question by giving or writing it on the chat room, or maybe you may deliver it directly by raising your hand on the thumbs up, and then. And as I've told you on a previous meeting, and also Pak Imam have told you, we will have 3 speakers from students of Kanazawa University who will deliver their project report. And also, but for it, we don't have any question and answer session. Okay, without any further delay, I would like to invite and greet Mr. Bagus, who have been here. How are you, Mr. Bagus?
I'm fine, thank you.
Yeah, thank you. So, are you ready for delivering your material today?
Okay, I'm ready.
Yes, I'm ready. So, let's us hear lecture from Mr. Bagus about basic concept of machine learning. Mr. Bagus, please.
Thank you very much, Miss Nida, for welcome. Good morning, everyone. First and foremost, ladies and gentlemen, let me offer my best regards to our Chancellor, the Rector of Universitas Amikom Purwokerto. He is Mr. Dr. Berliana MSI, and then the Dean of Faculty of Computer Science of Universitas Amikom Purwokerto, Mr. Dr. Eng Imam Tahyuddin MM, and our amazing keynote speaker, the Honorable Professor Hidetaka Nambo from Kanazawa Daigaku, Japan, or Kanazawa University. I would also like to extend my welcome to the student of Kanazawa University, Ogenki Desuka Tomodachi, maybe like this about the pronunciation, and participants all over the world whom I cannot mention one by one. Okay, and now let me introduce myself. My name is Bagus Adikusuma, and I'm a lecturer from Universitas Amikom Purwokerto, especially on computer vision field. Thank you very much for attending this winter course. Wish you good health always. I hope we can all deepen our knowledge in the subtopic of artificial intelligence in the basic concept of machine learning. Okay, let's get started. Please show my slide, maybe in the first slide. Next. This is our today's topic of discussion. We will talk about some basic concept of machine learning, how machine learning works, main group of learning and its application of machine learning, and then data set collection for machine learning, life cycle of machine learning, and the last is machine learning roadmap in 2020. Next. Okay, let's go into the introduction. So machine learning is a subset of artificial intelligence or AI. It is focused on teaching computers to learn from data and to improve its experience instead of being implicitly programmed to do so. So computational learning using algorithm to learn from and make prediction on data. In machine learning, algorithms are trained to find patterns and correlations or relation in large data sets and to make the best decisions and predictions based on that analysis. So machine learning application improve with us and become more accurate the more data they have access to. Application of machine learning are all around us in our home and then our shopping cart, our entertainment media, our healthcare, and so on. Okay, next.
Okay, so this is machine learning is our continuous topic about the previous one, yeah?
Yeah.
It's about artificial intelligence.
Yes, correct.
Okay.
So for the next slide, the analogy of traditional programming versus machine learning programming. So let's have a visual demonstration of what traditional programming is compared to machine learning algorithm. We see the chicken, raw chicken
Yeah.
there and vegetables. In traditional programming, let's say you want to cook your favorite roasted chicken. With traditional programming, you might start with a couple of inputs. So let's say you've got your box of vegetables and raw chicken. You may follow these steps. What are? Step 1, cut the vegetables. Step 2, season the chicken. Step 3, get the oven preheated. As for the correct temperature, that's up to you as the cook. There might be a passed down recipe from your grandmothers, maybe that's it, your palate. Cook the chicken for 30 minutes, add vegetables, and then if you've done all this correctly, if you started with the right ingredients, you've started with the right rules, that you've programmed yourself, you'll end up with this beautiful roast chicken like this. Okay. It's very delicious, eh?
Yes.
Whereas machine learning algorithm usually starts with a set of inputs and a set of ideal outputs. In this case, the ideal outputs is from our grandmother's roasted chicken recipe. And it might look at 100 or 1,000 different examples of these inputs and outputs. And then it's going to figure out the instruction to what the recipe is so rather than us. Okay?
So, is it possible if the result is a form of the form of chicken is in a form of a piece of in cutting in a pieces?
Yes, it's very possible. And we can add more data and more feature in the input, like vegetables maybe, and raw chicken, and maybe some ingredients like onion.
Other
And
ingredients.
we train the data, inputs and outputs data, and we train and we get the result. And the result is can be used to predict new data in the future, like that.
Oh, okay.
Okay.
So it will be the result will be various.
Yes, of course. Next, maybe. And now, we'll look the difference between traditional and machine learning programming. Is this figure we see that in traditional mode programming, data and program is run on the computer to produce the output. So we see the machine learning on the other side. Machine learning, data and output is run on the computer to create a program or a model. We do training in this step. This model can be used for predict new data that had never been known before to get results. So machine learning is like gardening or farming. The seed is the algorithm, the nutrients is the data, the gardener is you, maybe, and the plants are the programs, are the models.
That's
like
so
that.
sophisticated.
Okay, next.
Next.
Okay, machine learning comes in many different flavors. It depends on the algorithms and its objective. We can divide machine learning algorithms into three main groups based on their purpose. Number one is supervised learning. Number two is unsupervised learning. And the last is reinforcement learning. Okay. Let's talk about supervised learning. What is supervised learning? So supervised learning occurs when algorithm learns for sample data and associated target responses that can consist the numeric value or string label, such as classes or tags, in order to later predict the correct response when faced with new sample. The supervised approach indeed similar to human learning under the supervision of a teacher. For example, the teacher provide a good example for the student to memorize, and the student then derive the general rules from this specific example. So you need to distinguish between regression problem, whose target is a numerical value for the regression, and the classification problem in which the target are qualitative variable, such as a classes or tags. And as an example, the regression algorithm are advertising, popularity prediction, weather forecasting, and we will see any more, etc. And then the example of classification method work just like identity fraud detection, image classification, maybe text classification, and many more. As for unsupervised learning now, it occurs when an algorithm learns from plain sample without any associated response. Handling it over to the algorithm to determine the data pattern on its own. This type of algorithm tend to restructure the data into something else, such as new feature, maybe, that may represent a class or new series of uncorrelated value. It can be using unsupervised learning. They are quite useful in providing human with insight into the meaning of the data and useful input to supervised machine learning algorithm. As a kind of learning, it resembles the method humans use to figure out that a certain object or event are more from the same class, such as by observing the degree of similarity between each object and other. Clustering and dimensionality reduction are two subfields of unsupervised learning commonly used to identify pattern and yield valuable analysis. Okay, as an example of clustering are customer segmentation, targeted marketing, recommender system, and so on. As for the example of dimensionality reduction are big data visualization, meaningful of compression, and so on. Okay, so we talk about the last one is the reinforcement learning. Reinforcement learning occurs when you present the algorithm with samples that lack labels, as if in unsupervised learning. However, you can enclose a sample with a positive or negative feedback according to the solution the algorithm. Reinforcement learning is connected to application in which the algorithm must make the decision. Okay, not just descriptive in reinforcement learning, but is the prescriptive model in reinforcement learning. Okay, in the human world, it's just like learning by trial and error. So in reinforcement learning, we call it learning by trial and error.
Trial and error.
That's the reinforcement learning method. Okay, for the example are game AI, skill acquisition, learning task, robot navigation, real-time decision, and so on. Okay, next. Okay, this is the application of machine learning. Machine learning is the buzzword in today's technology, and it's growing very rapidly by the day. We are using machine learning in our daily life event without knowing, in such as Google Maps. Maybe Miss Nida know the Siri, and then Cortana maybe, Alexa, many more. Google Home. Maybe. Okay. Below are some the most trending real-world application of machine learning. There are automatic language translation, medical diagnosis, stock market trading, online fraud detection, virtual personal assistant, and so on. Yeah, until image recognition. Okay, next.
So can you give us an example uh, of the application of machine learning, especially in educational field?
Okay, I give one example in in image recognition. It's about attending machine
Attending.
based on face recognition. Yeah, the machine is recognize our face that maybe a lot of data we will train to build this machine, and then the machine can detect our face directly in real time, and but the machine still get error, some error, like maybe the accuracy is 90%, maybe the accuracy is 80%.
Okay, so it's still being developed.
Yes. So the application is still get error, but in the machine learning we try to retrain if we get the lower accuracy. So we improve the performance with some step, yeah, like hypermeter tuning, and then like give or add more data to the data train or in our data. So we will train again, and we can look the result, so we can improve the image recognition or face recognition with the next step I explain. Okay.
Okay, so for students who which campus applied this kind of application, please be careful, yeah, for your attendance. Okay, next.
Okay, next. Talking about the data needed by machine learning in this era, we can collect a lot of data from all directions, such as Google. In the Google process 24 petabytes of data per day, and then from Facebook,
10 million.
maybe 10 million photos uploaded every hour, YouTube video and Twitter, 400 million tweets per day. In astronomy field, like satellite data is in hundreds of petabytes. By 2020, the digital universe will reach 44 zettabytes. You know zettabytes? Maybe 10 of the power of 21.
More
Very
than
big,
just a gigabyte
data.
or tetrabyte.
Yes, zettabyte.
Zettabyte.
Okay, next.
Okay.
Okay, below are some of the kind of the data we might find around us, like text, number, clickstream, graph, table, images, transactions, video, and some or all of the above. Maybe you know the clickstream data, Ms. Lida? What is it?
Clickstream, I don't know what clickstream.
Okay, the detail, the clickstream is the detailed log of how participants navigate through the website during certain tasks. Jadi, so the log typically includes the page visited, and then time spent on each page, how they arrive on the page, and where they went when next.
That's so
next to the
detailed.
page, other page. Okay.
How
next.
about the sound? Can we input the data
Yes,
in a
of
form
course,
of
of
sound,
course.
voice?
From MP3, maybe from YouTube, and convert to sound, it's possible.
Okay.
Okay. So next, here is the interdisciplinary field of machine learning. Some of them are statistic, and then visualization, economics, databases, signal processing, engineering, biology, and so on. This is the interesting topics
That we
of
can
machine
develop
learning.
a lot of fields, yeah.
Okay, next. Okay, and this is the statistic versus machine learning. Maybe the difference between machine learning and statistic has been the subject of long-running debate. A debate so contentious at time that it has even become the subject of memes. Many machine learning techniques are drawn from statistics, for example, linear regression, logistic regression, and so on. In addition to other disciplines like calculus, mathematics,
Calculus.
linear algebra, and then computer science, maybe numerical, and so on. Yeah, it's very funny if you look the memes. Yeah.
Yeah, the illustration.
Okay, next. So now, what are the key differences between statistics and machine learning? Okay. Number one is purpose. The purpose of statistics is to make an inference about a population based on a sample. Machine learning is used to make repeatable prediction by finding pattern within a data set. It's number one. And then second, number two is data. Statistic does not involve multiple subsets of data because you are not trying to make a prediction. Okay, this is the pressure point. We not trying to make a prediction. Machine learning requires large amount of data in order to make accurate prediction. Okay. So number three is interpretability. Because of the large number of variables in machine learning data sets, the model developed from them can be simultaneously extremely accurate and almost impossible to understand. Statistical models, on the other hand, are typically easier to understand because they are based on fewer variables and the accuracy of relationships is supported by tests of statistical significance. The point of this modeling in this situation is to display the relationship between data and the outcomes variables. In addition, statistics relies on significance tests to determine the direction of magnitude or of a relationship, discounting noise and confounding variable. And machine learning models are built using training data and then fine-tune using a validation data set and are evaluated with a test data set. All of these steps help the machine to learn. Okay, next. The following are methods commonly used in the field of statistics and machine learning. In the field of statistics, for example, hypothesis testing, experimental design, ANOVA, linear regression, logistic regression, GLM, and PCA. So, as for in the field of machine learning, there are some method like decision trees, rule induction, neural network, SVM, supervector machine, clustering method, association rules, feature selection, visualization, graphical model, genetic algorithm, and so on. So we can see that the machine learning method sometimes needs statistical method to compute its algorithm. Okay.
So from these kind of methods, how could we choose one of which that is suitable for what we want?
We will
or
discuss in
to
our next slide.
our next
Okay.
slide. Okay, thank you.
So is more one valuable than the other? I mean the statistic if the best than machine learning, you really can't say that one is better than the other because they serve different purposes. Different purposes. It's
Yes,
like
of course.
comparing apple to orange. Okay, not apple to apple. The choice whether to develop a machine learning model or a statistical model will depend on your goal. So depend on your goal. What is your goal? Okay. Next. Okay, the best way to learn machine learning is to more practice with different projects. Maybe we can take some different field like biology, bioinformatics, and so on. And now I want to share you some data sets for your project. Okay, let's see. Most of these are free, but for some data set, maybe you have expert a little effort to deal with the copyright, maybe. So where can I download free? Common open dataset for machine learning. Yes, from Kaggle, from Medium, GitHub, UCI machine learning repository, and etc. From public government dataset like data.gov, EU Open Data Portal, etc. In finance and economics dataset, there are World Bank Open Data, IMF, Google Trends, American Economics, etc. And the next slide, please. Still continue. In image dataset for computer vision, many datasets. There are LabelMe, ImageNet, Elsan, MS Coco, Coil 100, Piso Genome, Google's Open Image, and so on. For NLP or natural language processing, we can download it from Enron dataset, Amazon Review, Google Books and Grams, Logger Corpus, Wikipedia links data, and so on. So in sentiment analysis, we can download it from Twitter, US Ireland Sentiment, Stanford Sentiment Tree Bank, Sentiment 140, and many more. And the last is for autonomous vehicles dataset. You can download it from Berkeley Deep Drive, BDD 100K, and Baidu Apolloscapes, Oxford Robotic Car, etc. Okay, it's many data we
Yeah,
can
that's
use.
a lot of data set that we can find, but
Yes.
actually this is the source comes from other countries, yeah.
Yeah.
How about Indonesia, Pak?
Indonesia
In Indonesia,
have little data. Maybe.
we still lack of data set, yeah.
Little data set.
Yeah, we may
Maybe
need to build
it's
it.
very privacy. So we maybe difficult to access it.
It's still
Okay.
difficult. Okay.
Okay,
So-
but we can try, we can search any data in Indonesia, maybe in association like NLP association in Indonesia, maybe have more data like medical data like X-ray, maybe in hospital, and magnetic resonance imaging. I think we can get access to the maybe laboratory like this or hospital.
Oh yeah. Or maybe we can create it by ourselves.
Yes.
It's too complicated.
Yes, maybe.
Takes time, yeah.
Next time. Okay. Next. And now, what is machine learning good for?
The function of
Okay.
machine learning.
Number one, a problem with long list of rules. When the traditional approach fails, machine learning can fill in the gap. So machine learning is good for problems with long list of rules, just like the self-driving. I give more example. If you want to code up a self-driving car, you'd have to code in everything, such as stop at stop sign, and then wait for pedestrian, finishing crossing the road to avoid collision, and then beautiful little dogs maybe that just run out and chasing a ball. So when the traditional approach fails, machine learning may help. And the second is,
Can make detection for it?
yes.
Oh, yeah.
Okay, the second is continually changing environment. So again, with the example, the self-driving car, the reason why I use such open cars, it's very easy to imagine this kind of scenarios if you were driving along and you're in your local suburb. Indonesia maybe desa ya, local suburb, you might know how to drive around pretty well. So you might be able to coding those rules for your local suburb pretty well, spot on. But then if you venture or visit let's say to another city with a constantly changing the environment, the rules that you have made for your suburb of where you live may not work very well. Your code, has been code in your local suburb is not working very well in other city or other suburb maybe. So in essence, in machine learning, is good for problems where it's required to adapt, aka learn about new scenarios. If we maybe venture to other city or other countries, maybe the solution, the machine learning is still accurate, still can detect our code, have got to best result, maybe like that. Okay. Next. And now, so here we can see the machine learning life cycle. This is the life cycle of the machine learning steps. The first step is gathering data. The second is preparation, data preparation. And the third is data wrangling. The fourth is analyze data. The fifth, train model. The sixth, test model. And seventh is deployment. So machine learning has given the computer system the abilities to automatically learn without being explicitly programmed. But how does a machine learning system works? How does a machine learning system works? So it can be described using the life cycle of machine learning. Machine learning life cycle is a cyclic process to build an efficient machine learning project. It's very efficient if you implement this life cycle. The main purpose of the life cycle is to find a solution to the problem or project or your project. Okay. Next.
Mungkin bisa dipercepat ya.
Okay. In the picture above, so this is the roadmap of machine learning in the white box in the center. To the left, there are 4 things that underlie the problem-solving process in machine learning. The first is a problem in the real world that can be solved using machine learning method. The second is how to learn machine learning algorithm. The third, which machine learning tools can be used to complete your work. And the last is related to the strength of mathematics with will be applied to machine learning algorithm in the future. If we have fulfilled these 4 preparation stage, then we can move on to the machine learning process. There are 6 process. Number 1 is data collection. Number 2, data preparation, train model, analysis or evaluation, deploying a machine learning model, and retrain model. Okay. Next, continue to steps in machine learning project in data collection. Please looking to the right side of diagram. The first step of machine learning process is data collection, which consists of question to ask and types of data. There are 2 parts, question to ask and types of data. There are what kind of problem are we trying to solve? Like what data source or they exist or not, what privacy concern are there, and then is the data public, privacy, and where should we store the data, and so on. For the types of data, there are structured data and unstructured data. Maybe structured data like in tabulated format, rows and column style, in Excel spreadsheet, can contain different type of data in other data. For example, numerical, categorical, and then time series. And unstructured data in example, images, video, natural language, text, speech, and so on. Okay, next. Okay, and the next step is data preparation. We see the right side. The part of the data preparation is explanatory data analysis, EDA, learning about the data you're working with, and then data processing, preparing your data to be modeled, and data splitting. Next. This is the core process or significant process in machine learning, is the train model. There are 3 steps. The most prominent process of machine learning is the train model. There are 3 steps: choosing algorithm, whether supervised or unsupervised. Choosing the type of learning. There are batch learning, and then online learning, active learning, transfer learning, and assembling. And the last one are underfitting and overfitting handling. We have to check the model or prevent it by validating the model, or do a hyperparameter tuning by running different model setting, like adjusting the number of layer, maybe in neural network, number of iteration, number of trees in decision trees, and more depending on the algorithm itself. Okay, next. And the next step is analysis or evaluation. The first one is evaluation metrics, such as we have to calculate the accuracy, and then precision, recall, F1, confusion matrix, mean square error, mean absolute error, R square, etc. And the second one is analysis, feature important. Should some be removed? Does it useful for model explainability? What feature is more important? You may be choose the feature is more important. The third is training or inference time or cost. Like how long does the model take to train, and then is it feasible? How long does the inference time take? and then is it suitable for the production, and so on. How about the cost too? Okay. Next step is deploying the machine learning models. This is the final step. Oh no, the final step is the retrain. Okay. Okay, the deploying a machine learning model to produce a user-friendly system. So we built the user-friendly system. In this step, we have to put model into production. You can use many tools such as TensorFlow serving, PyTorch serving, Google AI platform, and ML Ops, and so on. Next, the last step is the retrain model. Okay, please the next step on the slide, retrain model. Okay, see how the model perform after surfing in the previous step based on evaluation metrics, and revisit the above step as required. Remember, machine learning is very experimental. So this is where you want to track your data and your experiments. Okay, that's all that I can explain. The next session will be discussion. Maybe are there any questions regarding machine learning? If so, don't hesitate to send it us away. Thank you very much.
Yeah, okay. Thank you very much, Mr. Bagus, for delivering your lecture. And then before we go to the next session, that is a question and answer, I would like to remind you to fill the link of presence. You may see on a chat room that we have shared the link of presence, and then this is the presence for every meeting, because the link for certificate will be shared at the end of the session, that is day 4. Okay, thank you. So let's see some question. We will have maybe we will choose 3 questions. Anyone, participants who want to ask directly to Mr. Bagus, maybe? Or you may also write in on a chat room so we can read your question. Ini nggak nyala. Oh yeah, okay. Maybe a student from Kanazawa University. You want to ask something? Yeah, maybe. Because the explanation have been so detailed, even if the topic is the basic concept of machine learning, but Mr. Bagus have delivered it in details, yeah. So we just can say, wow. Ya, seperti
Maybe
itu
from
kira-kira.
Kanazawa Daigaku.
Kanazawa Daigaku. Sudah betul atau belum ya?
Okay.
Udah, okay. No question. Yeah, okay. So, thank you, Mr. Bagus, for your
Okay,
time,
thank you.
for your sharing knowledge, and
Okay.
maybe see you on the next session. Yeah.
Okay, thank you very much.
Okay. Oh, good. Okay. Wait. Yeah, maybe we need to have 1, 2, or 3 questions. Mana? Nggak kelihatan deh. Yeah, we're still waiting for the participant to give the question. Yeah. Okay, here is the first. The question is, yeah, here is a question from Hasri Akbar, yeah?
Okay.
Maybe this is our student from Amikom University, right? Yeah, he asked about the stages. What are the stages for making a machine learning? Maybe this is the same as the step of
The stage of machine
data
learning.
set, yeah.
Okay.
Steps of making machine learning.
I have done explain in my presentation that you have to wait. Maybe you have to see to backslide on the life cycle, machine learning life cycle.
Yeah, on machine learning life cycle.
The number one is gathering data. Okay, gathering data. What is gathering data? In this step, we need to identify the different data source. As data can be collected from various sources such as files, database, internet, or mobile device, it's one of the most important steps of this life cycle. The quantity and quantity of the collected data will determine the efficiency of the outputs. The larger the data, the more accurate the prediction will be. This is the first step in gathering data. Okay. Number two, I will explain again about data preparation. After collecting the data, we need to prepare it to further step. Data preparation is a step where we put our data into a suitable place and prepare it to use in our machine learning training. Okay. And the next step is data wrangling. What is data wrangling? In this step, data wrangling is the process of cleaning or and converting raw data into a usable format. It maybe depends on the program language, maybe Python or MATLAB or C#, and so on. It's the process of cleaning the data, selecting the variables to use, and transforming the data in a proper format to make it more suitable for analysis in the next step. It's one more important step in the cycle. Cleaning of data is required to address the quality issues. And number four is analyze data. Step number 4. Now, the cleaned and prepared data is passed onto the analysis step. This step involves selection of analytical techniques, building models, reviewing the results, and so on. The aim of this step is to build a machine learning model to analyze the data using various analytical techniques and review the outcomes. Using various analytical techniques, and then you review the outcomes. It starts with the determination of the type of the problems, where we choose the most suitable machine learning techniques such as classification, regression, cluster analysis, association, reinforcement learning, and so on. Then build the model using prepared data and evaluate the model That's number 4. And then step 5 now is the train the model. In this step, we train our model to improve its performance for better outcomes. For better outcome of the problem. Okay. We use data sets to train the models using various machine learning algorithms. Various machine learning algorithms like decision trees, SVM, neural network, naive Bayes, and so on. Training a model is required so that it can understand the various patterns, rules, and features. So the training model is required. It can understand the various pattern, rules, and features. So the next step is the 6th step, test the model. We need to check the accuracy of our model by providing a test data set. So data set is, we will separate into 3 parts: train model and validate, train data, validate data, and then the testing data. Testing the model determine the percentage accuracy of the model as the requirement of project or your problems. It's a very important step. The 7th, the last step of machine learning in the life cycle is deployment, where we deploy the model in the real world system, user-friendly system. If the above prepared model is producing an accurate result as our requirement with acceptable speed, okay, then we deploy the model in the real system, like web-based, maybe desktop-based, mobile device, and so on. But before deploying the project, we will check whether it is improving its performance using available data or not. We check again whether it's improving its performance using data or not. Yeah. So many programs can use, like Python, Google Colabs, collaboration, and then MATLAB, C, C#, Java, and the machine learning have a tagline like this: machine learning is for all.
Machine learning is for all. So
that's my explanation.
Yeah, okay, maybe one more. Yeah,
Okay.
one more, yes, sir. Okay, so where should we put or input the algorithm to make it as the machine learning?
Okay, we can treatment in train model. We input the data into train model. So in life cycle machine learning is the 5th step. Okay, train model.
Okay.
We input the train data and then validation data and we train and we test the model with the test data. The test data, the new data that maybe the system for the system is not seen before. Okay.
Okay.
Enough,
So,
maybe so.
yeah, okay, thank you, Mr. Bagus,
Okay,
for
thank you.
answering this question. And actually, there's still a lot of questions, but we couldn't have a lot of time here. So that thank you for your participation during this lecture. And then I'll offer it to maybe Mr. Nambo as the moderator from Kanazawa University.
Okay.
Yeah.
Okay. It's okay. It's turn from Kanazawa University. Is it turn from Kanazawa University?
Yeah.
Okay. So first of all, let me introduce my laboratory. Our laboratory. Our laboratory is Artificial Intelligence Laboratory in Kanazawa University. In our laboratory, we are developing some applications using AI technologies. So there are our application is in many fields such as medical or engineering or and so on. So today we our student make presentation in 3 fields. First speaker is Mr. Ryosuke Kasaba. He is a master course student, second grade. Today, he will present about his research. Title is Anomaly Detection in Vibration Data using Domain Adaption. So, OK ですか? So please start sharing your screen. スクリーンシェアリングできない。So, please make permission to share the screen from Mr. Ryosuke Kasaba. Can we share the screen? あ、なった。どうしようかな。私に来たんだけど。待って。ミュートの解除を求めるって名前のところに、こっち出ないですか。Sorry, just a moment.あ、多分もうすぐ大丈夫だと。できないですか。じゃあ、あれ。
Okay, so please be patient for the participant waiting for it while we still prepare for sharing the screen.
Yes. So, just a moment. しまった。
どれ
一番下の方に2020 12月のとか聞いていく。
あ、これ書いてある。
どういうふうにやったらいいですか？
いや、ここで。
はい、わかりました。イヤホン自分ので。
Okay, Professor Nambo, anyway, you are the host now, and you can,
Yes.
yeah.
Actually, I want to make host the
Ah.
student's PC.
Oh, okay, okay.
Okay, maybe you won't mention the name of the students.
Kanazawa University, but his name is in Chinese letter on
Oh,
the
yeah.
Japanese.
So we couldn't mention it, yeah. Okay.
出たいた
Oh yeah, or maybe
He's changing his name.
You write it on the chat room, sir, so
Yeah,
that we
yes.
can help you to write in the screen, so we can display it on the screen, the name of the student.
But he now changed his name in in alphabet. 変えたよね。
はい、
涼介かさば his name is いや涼介かさば R start R.
Ya,
Okay,
sudah.
could you find it?
Aduh, bocor. Ya, oke.
Okay.
Wait. Zhao,
So itchy. So itchy.
Reading.
Zhao, Kai, Ching. I'm sorry because our our technician haven't familiar with this name.
涼介かさば
Gimana?
I wrote his name on chat.
Udah di chat room?
Yes, AI winter course
Oke.
private message.
Iya, Kyusuke Kasaba. Betul. With the detail of the project, maybe, sir?
Make me post again. あ、そっか。これをどうするのうん。どうだ
Judul sama namanya gitu ya, Pak, maksudnya.
あれ見つからん。あ、sorry. OK. Changed.
Oke,
ここから
ready?
かさばくにする。
いや、よかったですか？
いや、もう今、ホスト券を返しちゃったから、向こうから来るんじゃないかな。しまった。Sorry, I returned host to AI winter course.
Udah?
So please make him as a host.
Ah, udah. Okay, so can we start? Or still waiting for? Ini lagi ngapain sih ya, Pak?
あ、いったね。お、少しとなった。Okay.
Okay.
Sorry for late. Let's start.
Yeah, it's okay. So our technician have already said. So, the presenter can share their screen. Yeah.
Yes, okay.
Okay.
始めてください、please.
Yeah. So, the presenter, please.
じゃあ、このままで。
You may deliver your report.
Hello.
And also, you may turn on your camera.
カメラオンにしてって。
Camera.
あれ？ああ、OK。
顔認証に切ってもらっていいですか？
あ、わかった。はい。
Yeah.
Hello. これ入ってます？ I'm 涼介カサバ。日本語でドメイン適用を用いた振動データによる異常検知、Anomaly Detection in Vibration Data Using Domain Adaption というタイトルで発表します。はじめに、研究背景、リサーチングバックグラウンドです。今現在、いろいろなものを作る工場ではさまざまな工業機械が使われています。そしてその工業機械の高精度化が進んでいます。
Excuse me, Mr. Kanazawa, you may turn on your camera so that we can. Oh, udah. Okay, thank you. You may continue your speech.
Okay. そこで、その工業機械の、部品の小さな部品とかに異常が発生してしまうと、その生産効率が悪くなるといった問題があります。そこでその工業機械の故障や異常を早期に発見するといった技術が今現在求められています。しかし、その機械を使っている工場によって温度や湿度といったデータを取得する環境の違いがあったり、同じ種類の機械でも複数の機種を同時に使用しているという場合が多くなっています。そこでそれぞれの機種や温度や湿度などの環境の変化に対応した異常検知モデル AI を作成する必要があります。しかし、異常検知モデルを一から作成するには、データの取得、型編だったり、DNN を実行する環境づくりなどにさまざまなコストがかかるといった問題があります。そこで、少ないデータ、コストで正確な異常検知を行うといったことが必要になってきています。今回の研究内容です。ある工業機械の機種 A ですでに学習を終えた異常検知モデル AI を機種 B に流用することができれば、機種 B の少ないデータで異常検知ができるドメイン適用技術というものがあります。そのドメイン適用技術を使いつつ、同時に GPU の導入など DNN の学習に必要なコストを少しでも減らしたいため、計算量の少ない CPU でも動くドメイン適用を利用すればいいと考えました。ドメイン適用とは何かなのですが、あるタスクに対して訓練されたモデルを関連したタスクに応用する転移学習の一つになっています。十分な教師ラベルを持つソースドメインから、作成したモデルを十分な情報がない、データが少ないターゲットドメインに適用することで高い精度で働く識別式を学習します。例えば下の図ですと、ソースドメインが、絵で描かれた、馬だったり自転車、飛行機なんですが、それを、絵で学習した、AI を用いて写真でも、識別を可能にしようというものです。今回の研究の先行研究です。小泉らの研究で、アダプティブバッチノーマライゼーション、通称 ADA-BN というものを用いたネットワークを用いて、3種類のミニ四駆と3種類の雑音環境で9種類のドメインを用意して学習を行っています。 さらに別機種と別の雑音環境のデータでテストを行っています。この図を見たらわかるのですが、ニュードメインのところ、すみません、戻る。ニュードメインのところで、今まで、通常の DNN の再学習である、2段目の、正答率が 0.874 なのですが、今回提案しているアダプティブバッチノーマライゼーションを使った方法でも 0.852 という高い精度を出していて、GPU を用いた学習でも、DNN の再学習だと 1.5 時間かかっているのに対し、提案手法だと30秒の再学習で済んでいます。そこで今回この技術を用いました。そして AdaBN とは何かといったものなのですが、バッチノーマライゼーションに使う統計量、平均や分散をそのソースドメインとターゲットドメイン、それぞれの対象が所属するドメインから算出する方法で、ソースドメインで学習したネットワークの全結合層などのパラメータを変化させずに、バッチノーマライゼーション層のみをターゲットドメインのデータを用いて再学習するといったものです。この手法はかなり計算量が少ないため、実装は比較的容易でコストもなかなかかかりません。今回使用しているデータです。大型ファンと小型ファンの2種類を用意して、大型ファンをソースドメイン、小型ファンをターゲットドメインとして、回転部分に加速度センサーを取り付けて 10kHz サンプリングで1分おきに1秒のデータを収集しています。ここで大型正常データを1004個、異常データ562個、小型正常データを1219個、異常データを50個収集しています。この異常データは二酸化ケイ素を溶かしたアルコールを中心部に突出することで劣化させて収集しています。今回の実験概要です。はじめに大型ファンの正常データ621個を用いて、大型ファンの異常検知を行うオートエンコーダーを作成して、大型ファン、小型ファン両方のデータでどれほどのスコアが出るかの評価を行います。その後、小型ファンのデータ150個を用いて、使用するデータ数を15、60、150の3パターンで変化させ、大型ファンで学習させたオートエンコーダーにドメイン適用学習を行って、小型ファンでの評価を行います。今回の実験では加速度データを利用しているのですが、加速度データをそのまま使用するより、各特徴量に変換した方がいいという先行研究がありましたので、この8つ、ピーク値、実行値、波効率、Y度、鮮度、形状係数、インパルス係数、マージン係数の8つの時間特徴量と周波数特徴量、FFT を128個使用しています。今回、まず、大型ファンでオートエンコーダーを作成して、それぞれ大型ファンと小型ファンの正常データ、異常データでテストした結果になります。左側が大型ファンのデータでテストした結果になっていて、ちょうど1800データくらいで異常データに切り替わるのですが、式位値を10くらいに設定すると、いい具合にオートエンコーダーとして機能していることが分かります。次に、大型ファンのデータで作成したオートエンコーダーに、ファン小、小型ファンのデータを入れてみた結果なのですが、当然なのですが、スコアが高くなってしまっていて、正常データと異常データの区別がうまくできていません。次に、データ数15、60、150でドメイン適用を行った結果になります。データ数が少ない、データ数15ですと、やはり途中のデータでばらつきが見られてしまうのですが、データ数を増やしていくごとに、小型ファンは異常データが少なくて、最後の方にしか異常データがないのですが、異常データがしっかりと区別できているように見えます。 この結果を見ると、先ほども言ったのですが、大型ファンで学習したオートエンコーダーに小型ファンのデータで、スコアを算出したグラフと比べると、ドメイン適用後は少ないデータのドメイン適用でもかなりうまくいっているように見えます。しかし、データ数を、ドメイン適用のデータ数を60から150に増やしたときに、結果が少し悪くなっているように見えるのはなぜなのかっていうのを考えています。最後に、今後の展望です。今回の実験では、ソースドメインもターゲットドメインも少量のデータで行ったため、データ数を増やしてもう一度行ってみることを考えています。また、そのターゲットドメインのデータが15個でもある程度うまくいっていたので、さらに減らしてもうまくいくのか調査しようと思っています。また、今は特徴量に変換して学習している加速度データをそのまま使用することと、一次元 CNN を使用してデータ処理をしてから加速度データを入力に使ってみることを考えています。以上です。
Okay, thank you. So it's Q&A time. I think it is better to write your question on chat. So is there any question from Amikom or our Kanazawa University?
Mana tadi? Oh yeah, from us we don't have any question because we just informed on when we start. We inform our participant that we will have no question session for this, but
Okay.
maybe if some participants want to ask about this project report, participant is allowed to give some question. Mungkin ada yang mau kenapa bahasa Indonesia? Ya, mungkin dari partisipan Indonesia ada yang mau bertanya, dipersilahkan karena ini ternyata kami kira awalnya tidak akan ada sesi pertanyaan dan jawaban, tetapi Prof. Nambo mempersilahkan kita untuk bertanya. So, silahkan kepada kalian yang mau bertanya, dipersilahkan. Kenapa? Ya,
So,
mungkin boleh di-share pertanyaannya di chat room ya, silahkan.
Oh, there is one question.
Ya, only
I just
one question.
I just wonder what math was used for that project.
Ya, okay, thank you, Prof. Nambo. Maybe
Okay.
while waiting for participant giving his question, oh sudah ada.
Yeah,
Okay, so we have a question.
Yes. So じゃあどういう数学的なものと言えばいいのかな。
Yeah, okay.
Thank you very much for your question.
Wait. Mana pertanyaannya, Coy?
特にない？
Ya, okay.
数学って言われると思いつかないですか？
難しい。It's a difficult question. Because we just applied the method already published in the paper, but the problem is we think new target. So we want to evaluate the usefulness of the result. So I'm sorry, we are not discussing about the theoretical aspect of our method.
Yeah, okay.
It's okay?
Yeah, it's okay, Mr. Nambo.
Thank you.
There is one question about the use of math.
Yeah. I just answered. Sorry, I just answered to this
Oh,
question.
udah jawab tadi ya? Oke. Okay.
Okay.
Thank you for
Thank-
your answer. So we may go to the next presenter.
Okay. Yes. So thank you very much, Mr. Kasaba.
Okay.
Okay, so let's move on to the next presentation. 次誰? Okay. Next presentation, the speaker is Mr. Eiju Kitamura. His title, his research theme is Study on Stylistic Transformation using Deep Learning. Okay, so, まあ、ホスト。もう戻ってる。うん、多分ホスト券そこにあるから、北村君にホスト券を譲ってください。Sorry, just a moment. We are transferring the host. あ、そう、ホスト券。なりました。うん、じゃあ、please start screen share. Okay.
Okay, Mr. Nambo.
Thank you. So he.
Yeah. Maybe the next presenter.
Yes,
should
the next
set it
presenter already
be-
starting his
Oh,
screen
yeah.
sharing. Can you see?
And make it as the host. So
Yeah. Mr. Kasaba transferred host to next speaker.
Yeah. Okay. Thank you.
でマイクオンになってます。聞こえない。
Okay, participant, while waiting for the preparation for the second speaker, you may also prepare for question that maybe can be answered by Mr. Nambo or by the speaker itself.
Okay. Please start your presentation.
はい、深層学習を用いた文体変換に関する研究と題しまして北村が発表します。今回の流れはまず導入、それから節句強化学習についての説明を行った後に今回行った手法2つの説明で、その結果最後にまとめと今後の課題について話していきます。まず導入についてです。近年人工知能を利用した商品が登場してますます人工知能が身近になりつつある中、文字を理解して文章を校閲構成する人工知能が存在しています。
もしあれやったら質問来てるから。
本研究では文章を読み込み新たに生成することによって文体変換することをしたいので、画像生成で有名なGANを系列データに応用した節句GANを用いて文章を生成することを目的としています。まずGANについて説明します。GANは対照的生成ネットワークの略で、2つのネットワーク、ジェネレーター、ディスクリミネーターの2つのネットワークをお互いに競わせて学習させる手法です。ジェネレーターは入力されたデータから新しい記事データを生成するネットワークで、ディスクリミネーターは入力されたデータが本物データかジェネレーターで生成されたデータかを予測するネットワークです。次に節句GANについて説明します。ちょっと行き過ぎたかな。節句GANは、ランタオユウさんが2016年に提案した手法で、GANと同様にジェネレーターとディスクリミネーターの2つを交互に学習する手法です。ディスクリミネーターの学習はGANと同様なんですが、ジェネレーターの学習には強化学習を用いています。で、節句GANはGANの問題点である系列を扱う場合、ジェネレーターの出力が離散値なので、ディスクリミネーターの学習が困難といったものに対しては、強化学習を用いて、 ジェネレーターを学習することで解決し、ディスクリミネーターは完全な系列データしか評価できないといった問題には、モンテカルロ法を行うことによってこれらを解決しています。次に強化学習について説明します。強化学習は環境とエージェントがあり、エージェントは方策によって行動を決定し、環境はその行動によって得られる報酬と状態をエージェントに返します。で、エージェントはまたそこから次の行動を方策によって決定し、でまたその行動によって得られた報酬と状態を受け取ります。で、今回ジェネレーターの強化学習の状態については、現在作成している文章の文字の ID の配列、行動は次の文字の ID、報酬はディスクリミネーターの評価値となっています。で、今回ジェネレーターをパラメータを含む確率的な方策とみなして、方策勾配法によってジェネレーターを学習しています。で、今回行った手法については、文章を変換するために強化学習の報酬について焦点を当てて考えてみました。あるデータに類似したものを作成したいと考えたとき、報酬イコールディスクリミネーターの評価値だったので、ディスクリミネーターに読み込むデータを変更することによって容易に作成できるのではないかと考えました。そしてもう一つが、そのデータから重要単語を抽出して、その単語が含まれている場合、報酬を加算することによって生成されるデータが重要単語を多く含まれているものが出来上がるのではないかと考えました。で、重要単語を抽出するときに、テキストデータから専門用語を取り出すための Python3 モジュールの Term Extract というものを使用しました。また、生成される文章の単語数には、ジェネレーターに読み込まれたデータに依存するので、今回はメールを、読み込ませたのですが、こちらのメールを複数用意しました。で、まず1つ目、ディスクリミネーターに読み込むデータを変更するについて説明します。今までは本物データをジェネレーターとディスクリミネーターに全て読み込ませていたものを、ジェネレーターはそのまま全部読み込ませ、ディスクリミネーターには本物データの一部だけ読み込ませました。で、今回扱う本物データのメールは、金沢大学から送られてきたメールで、熊の出没情報、コロナ情報、奨学金のお知らせといった内容の5通を使用しました。で、ディスクリミネーターに一部読み込ませる内容は、熊の出没情報メールを1通だけ読み込ませました。で、学習のエポック数は、事前学習ではジェネレーター60、ディスクリミネーターが30。で、本学習ではジェネレーター、ディスクリミネーターともに5回ずつを3セット行いました。で、一度に生成されるデータ数は、ディスクリミネーターに入力されるデータの数が、本物データとジェネレーターに生成されたデータの数が1対1ぐらいになるように割合に調整しました。で、こちらが、その結果です。ディスクリミネーターに読み込ませたデータの熊出没情報の単語が多い気もしますが、こちら数値的な根拠がまだ示せていない状態です。で、一応、本物データとジェネレーターで、されたデータの文章をランダムでディスクリミネーターが評価するテストを行ったところ、評価が低いものを見てみると UNK といった読み込みできなかった単語が多くあることによって評価値が低いものが多くありました。次に重要単語を抽出して含まれていた場合報酬を加算する手法2について説明します。こちらは今までと同様に 本物データをジェネレーター、ディスクリミネーターにすべて読み込ませます。で、本物データの一部をタームエクストラクトに入力して、その中の、して重要単語を抽出します。今回は、熊の出没情報なので、熊という単語が含まれていたら、報酬にプラス 0.1 するようにしました。で、今回の本物データは、手法位置と変わらず、エポック数も変わりません。で、一度に生成されるデータは、先ほども言いましたが、本物データと生成データがだいたい割合が1対1になるように調整しました。で、こちらが、その結果です。熊という単語がまた多く感じていましたが、こちらも数値的な根拠が示せていない状態です。で、また、重要単語、1単語だけだったので、そちらの単語数を増やして再度検証する必要があります。最後に、今回は2つの手法で、強化学習の報酬を変化させて文章を生成しました。どちらも有効かどうか数値的な根拠を示すまで至っていないので、生成されたデータを解析し評価する必要があります。評価方法については、単語の出現率を調べたり、ドックツーベックなどの類似度を調べたりします。で、また、読み込んだデータ数がまだ少ないので、そちらのデータを増やそうと考えています。以上で発表終わります。
Thank you very much. So, okay, so it's Q&A time. If you have a question, please write on the chat on Zoom.
Ya, jika ada pertanyaan mungkin dari partisipan Indonesia, boleh disampaikan melalui chat box sehingga Mr. Nambo bisa membacanya. Silahkan.
It's a little difficult because of the language problem. Presentation language is Japanese, and also the target is generating Japanese sentences. So,
Okay.
okay. So, okay. So, okay. So, can we move on the next presenter?
Yeah, okay.
Okay.
Maybe.
So, if you have a question, please ask Professor Imam Tahyudin. Maybe he will
Yeah, okay. Maybe that's
inform to
because
us.
they haven't prepared for the questions, so they just watching the presentation. Okay, thank you, Mr. Nambo.
Thank you. Thank you.
Yeah,
So,
okay.
let's move on to the third speaker. So, please, just a moment.
Yeah.
じゃあ、北村君から森田君にポスト検討してください。
Yeah.
北村君じゃなかった森田君を探して右なんか点々点をクリックするとホストをこの人をホストにするみたいなのがあるからでマイクこんなままやってた。
Ya, sembari kita menunggu mereka mempersiapkan untuk presenter yang ketiga, pembicara ketiga, silahkan untuk partisipan dari Indonesia yang mungkin akan memberikan pertanyaan, boleh dituliskan di chat room, and please mungkin bisa deliver it in English ya, supaya Mr. Nambo bisa memahami. Tetapi jika mungkin ingin menyampaikannya dalam bahasa Indonesia, nanti kita akan coba untuk translatekan kepada Mr. Nambo seperti itu.
diagnostic model for the relation of
Iya betul Pak, yang expired karena saya tadinya lupa nggak bisa.
real time relation using random forest. Complicated words because it is related to medical field research. So please start your presentation.
ランダムフォレストを用いた心房細動予防のための予測構築モデルの予測診断モデルの構築について森田が発表します。まずは研究背景から説明します。心房細動とは心房が不規則に興奮収縮して起きる不整脈のことです。で、この病気になると、心房内で血液がよどみ、血栓ができやすくなります。でその血栓が原因となる、心原性脳梗塞を引き起こす可能性が高くなるので、この病気の早期診断と予防が求められます。で今回の研究の目的は、健康診断のデータから、AFO、心房細動を検知できる、モデルの構築を目指します。使うデータは、金沢市の健やか検診のデータを使います。でこの検診データは、年齢や性別のほか、血圧などの測定結果、また起用歴などの100個以上の項目を含んでいます。2008年から2018年のデータを使います。でこのデータは、AF 発症者の割合が健常者に比べて非常に少ない不均衡なデータとなっております。研究方法についてです。使う機械学習のアルゴリズムとしまして、ランダムフォレストを採用しました。ランダムフォレストとは、右の図のような決定義を複数用いた、機械学習アルゴリズムのことです。で、ランダムフォレストは、台湾人を対象とした AF 予測診断モデルの構築の研究で使われていまして、AUC が 0.95% と、非常に良い結果を残しているため採用しました。ランダムフォレストのアルゴリズムについて説明します。ステップ1としましては、ブートストラップサンプリングと呼ばれることを行い、訓練データから復元抽出でデータを取り出し、複数のサブセットを作ります。ステップ2は決定義のモデルを構築します。作ったサブセットに対して、それぞれ決定義を構築します。で、ステップ3は予測です。テストデータを入力し、各決定義で予測を行います。最終的な予測結果は、各決定義の結果の多数決をして、予測結果を出します。次に不均衡データ対策について説明します。今回用いるデータは、発症者の割合が健常者に比べて非常に少ないデータとなっているため、そのまま訓練してしまうと、発症者は正しく検知できなくなる可能性が高いです。そのため、今回私はランダムフォレストのブートストラップサンプリング時に、アンダーサンプリングという動作を行い、健常者と発症者の割合が1対1になるように、調整してから訓練を行うことにしました。今回、私は実験を2つ行いました。1つ目は、健康診断データから今 AF が発症しているかどうかを予測する実験で、2つ目は、今ではなく5年以内に何%の確率で、各年何%の確率で発症するかを予測するという実験です。評価方法です。1つ目は、リコール、感度のことです。この研究の場合は、発症者を正しく検知できる割合になります。2つ目は、スペシフィシティ 得意度です。これは健常者を正しく検定できる割合となります。1つ目は AUC というものです。これは ROC 曲線という横軸に位置引く得意度、縦軸に感度を取り、判別機の式位置を変えながらプロットした曲線があるのですが、それの、下側面積のことで、この値が1に近ければ近いほど、このモデルの識別能力が高いということになります。実験1について説明します。実験1は、健康診断のデータから今 AF が起きているかどうかを予測する研究で、説明変数に健康診断のデータを用いて、目的変数に AF かそうでないかを、用います。訓練とテストを8対2に分割して実験を行いました。8割の訓練データで、ランダムフォレストのモデルを構築し、残り2割のテストデータを構築したモデルに入力し、その出る結果を評価します。結果はこのようになりました。イコールが 0.87、スペシフィシティが 0.91、AUC が 0.96 となりました。個人的には、イコールがもう少し欲しいという感じもしましたが、AUC が 0.96 とかなり1に近く、非常に良い結果が得られたと思いました。しかし、予防という観点では、今 AF が発症する可能性を予測するよりも、将来発症する可能性を予測した方が使えると思ったため、実験2を行いました。実験2は、AF が5年以内に各年何%の確率で発症するかを予測するという実験です。今回私は生存分析と呼ばれる患者さんがいつ死亡するか、その時間と死亡する確率を予測するという手法があるのですが、それを AF の発症に応用することで、今回の実験の実装を行いました。使うアルゴリズムは、ランダムサバイバルフォレストと呼ばれる、ランダムフォレストを生存分析に拡張したアルゴリズムを用いました。入力に健康診断のデータを使い、出力は、AF が5年以内に各年何%の確率で発症するかを出力します。実験1と同様に、訓練8、テスト2で分割して実験を行いました。結果です。まず左側に、AF を4年間発症しなかった人の発症率曲線と、右側に、4年目に AF を発症した人の発症率曲線の出力結果を示します。発症した人の方が発症率曲線が全体的に高く、差が見られたため、精度分析自体は失敗していないと思いました。ただ、発症しなかった左側の、図でも、4年目、5年目の発症率が 50% を上回っており、少し過大評価気味にあると感じました。次に AUC を示します。実験1と比べるとかなり下がってしまいましたが、5年間を通して同じくらいの精度で予測できていることが分かりました。考察です。実験1では非常に良い結果が得られました。これは、今の健康状態では AF を発症する可能性が高いかどうかを予測できるため、実用的なモデルが作れたと思いました。実験2ではあまり良い結果が得られませんでした。これを使う側からすると、信頼性に欠けるデータが得られるかもしれませんが、その何%ぐらいで発症するかというアバウトな指標を、出力するという点では、使えるのかなとは思いました。 今後の展望です。実験2の結果を改善することを考えます。実験2では、その生存分析に適したデータに加工する際に、データの数が全体的に少なくなってしまったことが、結果が上がらない原因だと考えています。そのため、データのかさ増しなど、データ数を増やす工夫をしたいと考えました。また、特徴裏選択などの機械学習のモデルを改善する手法を、検討したいと思いました。以上です。
Okay, thank you very much for your presentation. So the rest time is not enough, but is there any question? If you have a question, please write on the chat box on the Zoom.
Yeah, okay, thank you, Prof. Nambo.
Thank you.
Untuk teman-teman yang partisipan dari Indonesia, mungkin yang mau bertanya dipersilahkan, sudah dipersilahkan oleh Prof. Nambo. Ya, boleh tanya tentang apa aja, tidak harus tentang materinya juga nggak apa-apa, it's okay. Ya. Prof. Nambo, we still waiting for the participants to give their questions.
Okay.
Ya, silakan. Iya, nggak apa-apa. Nggak apa-apa, silakan. Okay, Mr. Nambo, maybe there is a question beyond our material, but beyond what the speaker says. How is the system of laboratory in Japan actually, especially in Kanazawa University?
System?
Yeah, the system of laboratory. Maybe about the use and the function. Seperti itu ya.
Related the research, now presented research.
Yeah, about the researcher and the work of it.
System. Oh, what the system you mean?
Maybe the procedure, Sensei.
Yeah, the procedure.
Procedure.
Yeah.
Mr. Morita's research about
No. About what is it? The procedure, how using the laboratory in Kanazawa University. I mean, yes, like the computer laboratory or the class laboratory, how the procedure or how the agenda. I mean, maybe the agenda.
Agenda?
Yes. I mean the
please
activity.
Japanese. Please in Japanese.
Agenda.
Yes. Activity.
I see. Yes.
Activity. For example, we are collaborating with another department. For example, Mr. Morita's research is collaboration with the medical department of our university. So he's applying the medical data. For the first speaker, Mr. Kasaba's research is collaboration with some company. Company. So he will using the real data measured in the actual plant. So the activity, some students are collaborating with other the department or some other companies. Or, for example, Mr. Kitamura's research is the original research of our laboratory. So there are many types of research or even system in our laboratory.
I see.
Okay.
Maybe what is it? The explanation about the daily activity in
daily activity.
Yes, daily activity in artificial intelligence laboratory in Kanazawa University.
Usually, the student come to the laboratory and developing their application related to their research. But nowadays, many students stay home and they works at home because our research actually our research can be done with personal PC. So they think they don't need to go to school, but I want they come to school. Okay, so I think it's not correct question, correct answer. Thank you.
Yeah, okay, thank you, Prof. Nambo, and thank you also for Prof. Imam for helping us understanding them. Yeah, okay. So, yeah. Don't, before we close this event or before we close this meeting for day 2, I would like to remind you who haven't filled the form of presency, you may click the link that we have shared. Maybe the teacher will reshare it. We will reshare the link on the chat room so that you can see it on the chat room. Okay, I think that's all. Yeah, before we close, we still have one more that we will do photo session. So for all the participants, please turn on your camera. Ya, all of the camera. Ya, partisipan untuk yang dari Indonesia juga mungkin silahkan untuk menyalakan kameranya karena sebentar lagi kita akan melakukan sesi foto bersama. Sudah siap? Oh ya. Okay, can we?